Thank you. I'll try to be short. I've introduced Blade as a low-level graphics API, and the point of that was that it's very fun to hack on. It's very ergonomic, and why not use the fun to build something interesting? So I've been talking about the asset pipeline on the last Gamedev meetup. Now I'm going to be talking about the next stage, which is like proper rendering and scene editing. So this is our README. This some of the demos, if you haven't seen them before, and this is my small helper slides. So first, we're gonna talk about denoising. If you remember last videos I showed, they were very grainy. You could see noise on all the surfaces. So here's what we have today. You can see it's pretty smooth. There's no like jumping of brightness in pixels. It's very stable, and it's real-time ray tracing. Like I can fly through that, even though I'm streaming this from a weak laptop. It's not a game laptop. I can stream and at the same time render this picture with real time. The only noise you see is the one where pixels become visible, which are not visible. Like, for example, look at the left of the screen. I'm going to turn. Yeah, there's a bit of noise on the left, bit of noise on the right. And that's because I'm aggressively using information from the previous frames. So there is a temporal reprojection that happens both during the restier part, which I think I mentioned the other day. That's the NVIDIA's magic sauce for proper ray tracing. But also, I'm doing reprojecting during the post-processing pass for smoothing everything out. There is a paper showing what I'm doing here. It's the SVGF paper. And in order to help you understand what's happening there, I'm going to disable all of the features I have. Disable denoising. And disable the temporal resampling and spatial resampling. So what we see here right now is a very noisy image, which is just a result of every pixel casting one ray into the direction importance sampled from the sky. So it's not a completely random direction, more or less random, because the sky is all bright. It's extremely noisy. Now, if we start temporal reprojection from this, I can crank it up to a level where it's almost good, still not very good. But we are going to start with one sample here. I'm using eGUI on the right to configure this. So this is way less noisy. And I can measure the noise actually. Here you can see standard deviation on the right. It shows the actual noise on the pixel I just clicked. So I can confirm not just visually, but also with numbers, what I'm feeling about the scene. So this is like 0.2, 0.3 kind of noise. Now we're going to enable the spatial reuse for the reservoirs. And you can see even less noise now. And let's see if the numbers are going to converge. I think they're already lower than what we had. Like we had 0.2, 0.3, and now 0.18. And visually, you also see that it's much better now. There's no, there's a bit of a problem with movement, but not as much as we saw in the beginning, because it's just one reprojection. It's just helping. But this is the result that you cannot ship, obviously. So this is where when people say we can't do real-time ray tracing, this is what they mean. Like this is best you can get, or around in the ballpark of real-time ray tracing without doing denoising. But denoising is not the worst part. Like, look, I just enabled denoise, and it's pretty cool. It's smooth. There is still texture detail on the surface. Oh, I'm in the wall. There's still texture detail on the surface. You can still see all the features of the scene, and it feels like it's just rendered correctly and just faster. So denoising is like a bit of a magic, and my denoiser is very basic right now. It looks at the depth and normals, and it separately blurs diffuse lighting from the albedo of the textures, so that we can still see the texture properly on the surfaces. Like here on the top, you see that the roof is still very, very nicely visible, and it does the temporal reprojection. So it's an interesting piece of machinery. If you're building your own ray tracer, I would recommend just looking at my code, because there isn't that much. You can easily port this to your own ray tracer. And of course, we can do much better than this. There's lots of stuff we can do to make it nicer. But this is fine for me. And I want to see how I can get something moving, get something flying or jumping or like driving on top of this, because it's already looking well enough for me. So the next thing we're going to talk about is Gizmo. And I'm going to not load the sponsor scene and instead just load the example, slightly modified so that we only have a plane here. This is just a plane. What we're going to do is we're going to go to the GLTF sample models and say, okay, core set. Let's go to GLTF core set, and we're just going to drag it on the scene. Boom. Where are you, core set? Oh, here you are. Very small. So there it is. Now I can right click it. Now you can see some interesting artifacts on the bottom. I haven't figured out what's happening there. Some future work, but that's not the point I'm trying to show. So I right click it. I see on the left there is a list of objects. There is a scene name. There's a list of objects. There's a plane, and there is a core set, and it has translation, rotation, and I can just I can just move it. I should be able to just move it. Oh no, look, like I broke it in one of the updates. Feels like I was tweaking something and I broke it. Oh, that's embarrassing. Don't tweak too much before showing your stuff. I guess that's the lesson here. But what we're seeing here is eGUI Gizmo, and it allows me to manipulate objects. I think while this is happening, I'm gonna quickly load something like this. So where we're talking. So eGUI Gizmo is this wonderful thing that allows you to show the gizmo, which we just saw, and manipulate objects. And I integrated eGUI in the engine a while ago. I was showing some eGUI before, and now I have Gizmo integrated as well. It's very good for scene manipulation. So I have a list of objects which I can just drop in more objects onto the scene. I can move objects around and rotate them, and I can save and load the scene. That's the basis of the editor, basically. It's gonna finish compiling in a second. Linking is unfortunately taking time. All right, here we go. Okay, so in this revision, we had the monkey head still. That's fine. Just gonna drop. So it's cooking the asset now, which is expected. In this version, I think I didn't compile with the dependencies with optimization. So the cooking of the asset is a little bit slower than on the version that I was showing you. Some of the hacks were actually useful, guess not. And it's also showing the black screen while cooking, which is something I fixed in the latest as well. So I'm gonna let it cook. This is most of the time here is taken by just compressing the textures into the DXT format. I'm using Texpresso for this, and Texpresso is notoriously slow if compiled in debug mode. So that's something that's gonna just take some time for it to process. It's doing multiple textures on different threads, which helps, but it's still, it can take like 30 to 60 seconds for a texture for Texpresso. So something that I recently did is just switching it as a dependency to always be optimized, which makes everything much nicer. Okay, so hopefully we can see something here. I'm gonna maybe show a bit of this while we are looking, and maybe look ahead in my slides to see if I can talk about something. Yeah, we talked about the ability to drag and drop. I think it's just a matter of showing how it works. So presumably, if we come back to this and this works, we can I can talk about some of the features that I want to get in the next phase of the project. So one of that is that my scenes right now are just hand-defined RON files. So they're certainly deserialized files that you can hand edit. And I'm thinking if we can use something more standard like USD, it seems like it would be a lot of work. If you have worked with USD format from Pixar, I'm curious if we can get something rolling in Rust, because in C++ there is at least a library that allows you to parse the format, and it's not Pixar giving like a third-party library. It would be nice to have something very Rusty here, something like winit, but for USD, something we can all use. The other thing is I was talking about like how ray tracing features are implemented and how it's all real time, but I only support very limited set of physical effects right now. So I don't do any specular reflections yet, and I know that specular is going to be difficult and it's going to make it slightly slower. I would need to cast an additional ray potentially from every surface because it's the like BRDF driven ray. If you have a perfect mirror, you don't want to sample the sky where the sky is most bright. You want to sample the sky where your reflection is going to go from. So it's a different kind of sampling routine that I will need to do. And of course, I want the local lights to be supported. And by local lights, I mean anything that can emit light. It's not actually a point light that you place somewhere. It's more like this object on this material needs to emit light, so it serves as a light source. And if you need like a street light or something, it's also a mesh. It's just an object with an emissive material, and all of the other objects will need to consider sampling that light into them to do anything useful. Okay, that's interesting. We're still doing some cooking. The other thing I wanted to mention is that pretty much everything is ready for the release. Obviously, I need to fix the Gizmo thing, and there's a few libraries that are still publishing, like the Zune library is providing the image decoding. And once it publishes all of its crates, I'm going to release Blade 0.3 series of crates. And this is going to be the crates included are Ego integration, low-level graphics, the rendering, which is like the ray tracing meat of it, in the asset pipeline. I don't expect it to be widely useful, but it's good to play with, I think. Okay, it's not, I don't know what it's doing right now. Oh, it's, yeah. Okay, it's not doing well. So what happened is that I broke things repeatedly for multiple ways. So once I broke it so that local textures are not read properly, and this is one of the features also important that I was implementing that allows you to drag and drop GLTF files with built-in textures. Oh wow, what's happening? What is happening? Everything is broken.
Yeah, I think like the last several times I like demoed a project or something, like I don't know, you feel like you can just keep committing right until it's ready to go out, and then yes, you very much realize that everything is not going
Wow. Yeah. Wow. I don't know what's happening. Maybe I need to come next time and show
Oh, good.
this.
Oh yeah. I love when you come back. It's always great hearing about Blade. I'll give you some of my stream of consciousness while I was like watching it. I think one of the coolest things about Blade that I see is like the artifacting could actually be such a cool effect to have. Like if you have like a horror game or something where like the way that it's rendering is something that you'd want to add in post processing anyways, or you could like use that as a constraint, that it would be so cool to use Blade because if I'm not mistaken, it would give you some really high fidelity graphics at a lower cost than alternatives, right?
Are you talking about the visual artifacts or just the ray tracing pipeline?
Well, I guess like the ray tracing pipeline is like, if I'm not mistaken, it's like a lot more efficient than other ray tracing pipelines, right?
Yeah. It's like it's real time. Again, it's a very it's a weak business laptop that I'm running and streaming at the same time, and it's running real time basically. So you can, if you have any kind of discrete NVIDIA GPU, it's gonna fly on your machine.
Yeah, because I think like definitely there's a lot of games that I could think of that have an aesthetic like this. Like so, I mean, like one of my favorite ones is like Return of the Obra Dinn. Like the way that everything is sort of in 3D. It's like pixel point art, I guess, pointillism. And then similar with this one, like as you move your camera around, like stuff kind of like comes in on the outsides as it like gets, I guess, like the denoiser goes across it and
Right.
stuff. I can certainly see that games would like to have, or like could definitely build around this type of artifacting.
Yeah. I think I know precisely what you mean, and the number of different weird visual effects you get for ray tracing is amazing. So I don't know if I have maybe I have something like this. One of the effects I enjoyed greatly was, oh no, I don't think I have it. This is some of the stuff I was playing with like just spawning a bunch of buggies and rotating them. Something I wanted to show, but I can't. But if you get the reprojection slightly off, just a little bit off, what you would get is that pixels are gonna slide slowly in time, and it looks like a rainy surface that like there's just
Oh,
water flowing through it. It's amazing. So there's so
interesting.
many visual things you can do, and the stuff that you mentioned, just like disocclusion noise. I'm looking forward for the day where this is actually solid fixed in the engine itself. So engine will just realize that, oh, for this pixel I need more information, so I'm gonna like cast more arrays or do more aggressive spatial search or something, and then like it's gonna look perfect. But then on the game side, you're gonna like simulate the same thing and
Yeah,
basically
exactly.
re-implement the noise that would otherwise be in the game. Yeah, that would be good
Yeah.
times.
Yeah. And actually, just out of curiosity, for like downstream, someone using this, is this something that you can like put into either WGPU as a backend or into something like Bevy as the rendering backend? Like, where might it fit in different projects?
Yeah, good. If you're talking about ray tracing part of it, you can technically port it. It's probably gonna be easier to not port the Blade Render crate itself because there's not much Rust code in there. All the magic happens in the shaders. So what you need is and it's using Wixel shaders. So the only caveat here is that um, in shaders I'm using ray tracing features that I landed in Naga. So they are not standard voxel features. If you're using Naga for your work and you target Metal or Vulkan, then you can just port my shaders to your engine and get something similar. Yeah.
Okay. Okay. That's super cool. So it's kind of composable from like a lower level than necessarily the entire engine. Like you can take different parts here and there, or and so I guess like the main idea here is that what you've done is implemented the research paper that's talking about all these cool and novel ideas, and you're kind of seeing how it would work in a full engine form.
Yeah, yeah. Of course, it's more. It's not just research. It's actually trying to make the code readable, because if you read the paper's code, it's amazing how research scientists they're like
Mhm.
they don't care about engineering this. They care about the final outcome, and their code is often unreadable. But
Yeah.
yeah, I think my code is very readable, and it could be a good source of learning. And I also talked about another thing that I did a while ago, which is like ray tracing on the ASCII terminal. Remember that one? It's like ray
I
tracing
believe.
playground. I think I
Mhm.
showed it where this was meant to be educational.
Mhm.
I don't know if I'm gonna port all of the new things in there, or people can just look at this project and instead learn from here.
Mhm. Yeah. Okay. Yeah. This is very cool as like I guess an educational step for some of this more complex rendering side of things. Um, is there anything else that you want to go over today?
No, I think I'm gonna go back to fixing things.
All good. Sounds good. All right. Well, thank you for coming out and showing off. I think it's super cool to kind of, yeah, be able to see what those steps look like when you go from the base version to that process of resampling and then denoising. It's really cool to kind of see those sliders.
Thank you for having. Looks like we're live. I
Yes. All
just
right.
want
We're
to
back. Yes.
finish on a good note. So nothing was particularly broken. Something with the asset confused the picker. I don't know what, but this is the same scene, the same code, and I'm just like dropping things on the scene from my right pane, which are you can recognize the famous Kenny's assets in here. So these are like things dropped here. Like I can select it, I can move it around. You can see that there's the coordinate system is a little bit offset from the actual object, because that's how Kenny's assets are made. That's not because I'm doing something interesting. But yeah, I can scale it. I can add objects, remove objects, rotate, and then save the scene. I can like select an object and delete it from the scene. So the TLAS, the acceleration structures are like updating every time I change anything. And you can see nice ray tracing artifacts whenever you move things, which I'm going to work on. But yeah, scene editing works. I can compose scenes and load them. So that's all I wanted to show. Thank you.
All right, perfect. Yeah, and it's just cool to see that all coming together. And yeah, I mean, also just being able to play with it and kind of load in stuff and then see, because I guess like when we look at it one scene, we get like one view, but like seeing the objects here kind of is definitely like a little bit different. Um, and so kind of seeing how stuff looks when you move around. It's definitely, I mean, for objects, it's not as much artifacting as I thought it would be. I guess like when you're moving around the world in 3D, it's a lot different than when you move the object itself. Yeah, but
Oh,
it looks so
yeah,
cool.
everything versus just one object artifact. Yeah, yeah. We'll get there. But even like this, if you look at the shadow beneath this guy, this already looks
Mm,
like it's global illuminated, even though
that's so
there's
true.
just
Yeah.
one ray cast. Like you don't get this shadow on a rasterizer if you do an editor. So this is
Yeah.
already pretty cool.
Okay. Awesome. Oh yeah. Good to see that this is all working out here. Yeah. So yeah. Again, thank you for showing off, and we'll catch you next time.